the more that you can understand about the environment, the better you can be at predicting. So if you can work out what piece of information is missing, then you can actually improve, and you can improve the probability of the answer that you're giving.
Yeah.
Amaro was a futurist, and he was the one who coined this idea that we tend to overestimate what's going to happen in the short term and underestimate what
Thank you for
actually
reinforcing the
happens
point that I had
in
never
the
heard
long
of.
term. And often people attribute that to Bill Gates, but it was actually this guy Ray Amaro, who,
Right.
and designing electronics these days is a lot like writing software. In the world today, there are about 25 million software developers. GitHub maybe has 80 million.
Hello IPXers, we are here today with Nigel Toon, who is the CEO of Graphcore. Now, you might wonder, why would we be with the CEO of Graphcore? Because that's not normally the kind of people that we talk to, apart from the fact that Nigel is indeed a disruptor and we're only about disruptive content. But we're here as a follow-up from our CES videos where we talked all about AI. He is now a published author on a book called How AI Thinks. Who else could we better talk to find out about that subject, see how he thinks about it, and to tell him all, and for him to tell us all about his new book. So, when I was a small boy, I used to watch a program called Tomorrow's World, which I think you probably remember too.
I do.
Yeah, indeed. Now, he's done this very brave thing. He's decided that he's going to look into the future and see what AI will bring to our world. So the first question we're going to ask him is this very cliched one of not only how AI thinks, but how he sees AI affecting our future. So Nigel, over to you.
Gosh. So AI is like a tool. Simple way to think about it is it's like a piece of paper and a pencil. So when you're solving a difficult problem, you don't just try and do it all in your head. You sit down with a piece of paper and a pencil and you write it out and you think about it and you use this thing outside of your brain to augment your intelligence. So AI is like a piece of paper and a pencil, but on steroids. It will augment human intelligence. It will help us solve problems that we currently can't solve on our own. It will let us look at complicated things in a way that we couldn't understand them just on our own. Good example, there's been massive progress in understanding how proteins fold and work.
Yeah.
So up until a few years ago, we maybe had models for a few thousand proteins. Then some initial work on AI got us to the point where we had 100,000 proteins and how they would fold. Now we're up to like 2 million different types of proteins, all of the proteins that exist in the human body. We sort of have a sense of how they fold. It's not perfect yet. We don't have the full sort of 3D structure of it all, but we're starting to understand how these proteins work. And so you take a molecule, you connect it to a protein in a cell, you attach a drug to that molecule, and it will connect with the proteins that then connect with the cell to deliver that drug right into the appropriate cells. You don't get any side effects, so you work out how to solve cancer. And a bit like a computer game where maybe AI can learn the computer game and learn how to win at the game. If it can understand the environment of proteins and molecules and how they interact with DNAs and cells, then it can work out how to win the game of killing the disease.
Yeah.
And keep us safe.
Yeah.
So that just one example of how AI is going to completely transform. It costs about 1.4 billion to develop a drug today, and maybe that's reduced by a factor of 10.
Right. So in that case, if you look at our community, we're all about disruptive technology, and we were at CES, and we've got about 20 videos on AI. And in all the examples that we saw, incredibly clever companies, incredibly chip companies. Now, your background is silicon. Your background is helping create and run companies silicon based.
Yep.
So in that terms, when you just described that brilliant medical, because I naturally think of AI as a sort of natural how do you make the world a better place rather than worrying about AI making the world a worse place.
It's a powerful tool. I'm sure we'll come to that.
Yeah. Is that from so our audience is trying to understand how they create better systems. What we heard a lot of was much better and efficient data analysis rather than adaptive learning. So where do you see AI today in terms of much faster and efficient data analysis, and where we start to step into adaptive learning for machines?
Yeah, it's interesting, isn't it? If you look at one of the places AI is being used quite a lot today in embedded electronics, for example, is around sensors.
Yeah.
So sensors have certain characteristics. Maybe those characteristics change with voltage. Maybe they change with temperature, or some other external condition. And so with AI, you potentially can build a much better model of understanding the data that the sensor is giving you and turning that into information that is then relevant for the software to understand. And what it's really doing is it's taking context into consideration. The difference between data and information is context. So if you understand what the temperature is, you understand what the voltage is, you understand more about what data the sensor is giving you, and you can adjust it to actually operate in the environment that that sensor is currently operating. So AI is being used a lot for that type of thing. So you're probably not aware, but on a mobile phone screen, for example, we will have touch. The difficult bit of the touch screen is when you get close to the edges, because actually the sensors change right close to the edge of the screen, and AI is being used to adapt so that the touch is consistent across the whole screen, and it has to do that fast enough so that the mouse moves with your finger. It can't be slow, so that the mouse is running behind your finger. It needs to be fast, and so there's pieces like that are being done today, but that's quite simple stuff.
But in that case,
that's quite simple stuff, and
in that case, that's not the machine learning, is it? It's still data analysis. It's quick, fast data analysis. The finger's moved.
No, it's so. What is AI? And how's it different from what we're conventionally used to? And I think the definition of that is really quite simple. A computer program asks you to describe everything step by step in a program. And so the machine is following an explicit set of commands. AI, the machine has learned from data, more specifically from information, to build a knowledge model that it's then making predictions from. Now, what's quite interesting about that is the answers aren't definite. So there's actually in life, there's very few things that you can actually do a fully deductive inference from, as Aristotle would have said, where you have all the information and you can come up with a complete set of commands that describe this is going to happen. There's some cases where you can do that, but in most cases there's either you don't have enough information or there's some change in the environment that means the best you can do is some kind of prediction of what the best answer is. Just think about crossing the road. Do you have all the information you need to cross the road?
No, you do have to cross the road.
But you're making a judgment that car's probably far enough away and it's probably going at a slow enough speed that you've got enough time, to walk across. You're making a probabilistic judgment, and that's what we do in life. And as a result, and as I say in the book, humans err, right? And machines
Didn't
that
someone
rely
say that famously once?
machines that rely on AI will equally err, hopefully less than a human would. Hopefully it will be able to build a better, if it can understand the environment well enough, it'll actually be able to build a better judgment. And the other thing is AI should be able to tell you what the probability of the answer is that it's giving you, as well, whether it's high probability or it might be misled by something, but it should be able to give you a probability of what it's saying. And then you can start to use, and this is your point about adaptation, then you can start to use feedback mechanisms that might actually improve on the probability of the answer. So this is the idea of reinforcement learning, for example,
Yeah.
or probabilistic systems, which are all based on this 1700s Scottish priest who was actually trained as a mathematician called Bayes. The whole idea of Bayes' theorem of how the more information.
You're taking me into completely uncharted territory there. So
the more that you can understand about the environment, the better you can be at predicting. So if you can work out what piece of information is missing, then you can actually improve, and you can improve the probability of the answer that you're giving.
Yeah, I understand. So there's sort of two things going on there then, isn't there? Because obviously we use this word adaptive, and because obviously the feedback that we got, shouldn't use the word obviously, but anyway, from CS was a lot of quicker data analysis against a data set.
Yeah.
Not the world that you're describing in the book, or at least trying to help the layman understand what AI is going to bring. But the point that you're making there, I think, is that you're saying that, in fact, the more that you can make those decisions and understand the context of that data, you'll make it.
So what you're doing is, sorry to interrupt, but what you're doing effectively is you start with data. So let's imagine you've got a bunch of numbers. What do those numbers relate to? Okay, I give you some context and say these are the dimensions of a box. So, and if I've got a starting point and these dimensions, I can actually work out what the shape and size of a box is. So that's now I've got information. From information, if I can understand how pieces of information are related together, I can build knowledge. Yes. And that's really what you're doing in AI, is you're building a knowledge model which is based on data that you've made into information, and you understand the relationships between these different pieces of information, and you build up a knowledge model so that when you see a new piece of data or information, you can work out, okay, how's that relate to what I've previously seen? Can I make a prediction of what the likely outcome would be? So that's an inference that you're making. But to make the inference, you've got to build a knowledge model. And the inference allows you to make an intelligent answer. So from knowledge, we get intelligence. So it's that sequence of data becomes information. Information allows us to build knowledge. Knowledge allows us to build intelligence.
Yes.
And AI is the piece in the middle that's building that knowledge model. So how complex that knowledge model is, what understanding it has of the environment, how good it is at making those inferences are, and how reliable it can be, is the quality of the AI. So, if you can understand the environment quite well, like a sensor, and how it changes in different conditions, you could build a pretty good knowledge model of, okay, based on this information, this is the answer that I would give you. If it starts to go outside the bounds of what it knows, then, well, now it's guessing.
Yeah. So,
again, to use a sort of Aristotelian analogy, there's extrapolation and there is interpolation, which I don't know if those are terms that people have ever heard, but...
We're very good at TCAP making words up.
So interpolation is you've got two pieces of information, and this sort of sits somewhere between the two.
Yeah.
And so you can make a good guess about what this thing in the middle might be, because it's not. So your television, for example, uses interpolation to fill in the missing information to decide, okay, so this pixel should be a little bit green, so then that makes the picture look better. Extrapolation is where you're off the charts. You've gone beyond the information that you know, and now you're guessing. And what you would typically do as a human, and humans get this wrong all the time, is you would extrapolate on a sort of a linear curve. So you might, for example, think because semiconductors have kept on getting better for the last 60 years, that they're going to keep on getting better at the same rate forever. And that would be an extrapolation, but you would be wrong, because more information would tell you, oh, actually the rate's slowing down, Moore's law is coming to an end, semiconductors aren't going to keep getting better and better. And so that would be a sort of a naive extrapolation. But imagine a situation where, you're in the 1500s and you've just stepped onto a sailing boat and you're sailing across the Atlantic as one of the first people, you've got no clue what you might find over there. And so you're extrapolating about, what that's going to be. Oh, we're not going to hit America, we're going to hit, the East Indies, and, you're making all these extrapolations which are all completely wrong.
Yeah. So just thinking about that, because you started talking about human beings, and of course I think what's interesting about the fact that you've written a book, which I think we should talk about a little bit more in a minute, but it's what you've very poignantly, I think, pointed out, first of all, is using a whole new word that I'm not going to be able to pronounce again, so I'm not going to even try. You're going to have to do that.
Interpolation.
Yep, that word. Yep, well done, thank you. Thank goodness you're here. For lots of reasons, thank goodness you're here. But what you've described is that human beings, you sort of mentioned that human beings just sort of make this huge, great big binary leap of faith, which is very polarising, and therefore, the end of the world is nigh.
Yes.
But what you've actually described is, and that's very interesting, not just for our community, which is trying to work out how all this fits in, but for the broader community, which is actually, all of this is incredibly incremental. It's going, each time each time data gets analysed, each time something happens, it's not all what I think what you're describing. And please correct me if I've misinterpreted it, but we're not rushing into this AI revolution where we're going to wake up one morning and the world has completely changed. It is going to be very incremental. So we're going to have more control as we move forward.
Yeah.
Did you say that, or did I interpret that wrong?
No, I think that's right. So there's something called Amara's law.
You're exhausting with all the things that you're coming up with. For goodness sake, I didn't think I was coming to get a PhD in science and philosophy. But anyway, that's what I'm getting.
Amara was a futurist, and he was the one who coined this idea that we tend to overestimate what's going to happen in the short term and underestimate what actually happens. Thank you for reinforcing
the point that I had never heard of.
And often people attribute that to Bill Gates, but it was actually this guy, Ray Amara, who came up with that originally, and that is typically because as humans, we're very bad at dealing with extrapolation. So something incrementally gets better, but over time, what does that mean? Classic mind teaser question, which I'm sure all your audience will get immediately, is let's say you have
apart from me.
Let's say you have this plant that doubles in size every day on a pond, and it takes 12 days to cover the whole pond with this plant. How long does it take to cover half the pond? So if you just think about that quickly, you might think, 6 days. No. It takes 11 days to cover half the pond, and then the last day, the whole pond is. You come back the next day, and the whole pond is covered. Yeah. And that's this. These incremental improvements actually result in massive changes over the longer period, but you don't notice it.
Yes.
While it's happening.
And when I said that, you did look at me. You actually. And I thought, I'm saying something that's wrong here, and I now understand why you thought that. But I think we're probably having the same thought, but in a different way.
Yes.
I can't quote deep philosophy and deep science, but I can hold a relatively intelligent conversation for the best part of 15 minutes if I'm lucky. Anyway, so that's very interesting. That's if you like, that's the electronic side. Now, you talked to you've introduced this whole futuristic side or the futurist interpretation of the world. Now, I mentioned to her as well at the start of this, I can't help but go into the cliched land of having a published author who's laid yourself bare by writing a book about AI and how AI thinks. So, and because of that, I can't help but then ask you the question of where is this all leading us? Read the book, which we'll show at the end of the video. But where do you see? I asked many people this at CES, and I sort of said you're lucky if you can see the next year, realistically. But beyond there, where you see the real, I mean, you've mentioned medicine. For me,
Yeah.
medicine is a huge one where it makes the world a better place.
Education, technology. So software and designing electronics these days is a lot like writing software. In the world today, there are about 25 million software developers. GitHub maybe has 80 million people that access it, so maybe there's some more than that. But that's like tiny percentage of the world population who are actually programming computers. In the book, I describe it as a bit like monks sitting in monasteries in the Middle Ages, the smartest people of their day writing out these illuminated manuscripts on vellum because we didn't have paper and we didn't have printing presses. They spent their whole day doing that, and it's like software engineering is a bit like that. The smartest people that we have, sitting there in front of a computer screen telling a computer what to do step by step in a program. And so imagine how AI improves that. Well, people think, oh, well, it will help them come up with, software ideas. It will help these software engineers check that their software is correct. It will add documentation to describe the software that they've written. And those things are all happening already today. But imagine that you've got a framework where you want to now program a computer. And so this framework lets you pick some objects for a computer game that you want to create, for example. So generative AI generates some, ideas, based on some simple prompts that you give it of the kind of players you want in this computer game. I want a whole bunch of killer turtles or whatever your silly idea is. You then want to say, okay, I want the background to be, a desert island somewhere with these killer turtles. So it, generates pictures of, possible desert islands for you. And then through this framework, it lets you describe what the gameplay is and how things move and, various things like that. You, without having to program, are actually programming a computer game that you can then launch. Somebody else can look at it and they can say, oh, it's great, but I don't want it on the desert island. I want it in the middle of a jungle or something like that. And so they change the backgrounds. They could adapt it and change it how they like. People will be able, this generative AI thing is almost misnamed. It's not the fact that it generates something. It's the fact that you, as a normal person, are telling the computer what to do and what output you want. So it's like a different form of programming that AI is allowing, and it will transform who can write code, who can control computers, and who can get computers to do useful things. Going back to our medical analysis, that person who understands about proteins and biology and molecules and all that stuff, they don't need to become a computer scientist or learn computer science. They can just have a framework that allows them, where AI will take them through and build the environment that helps them model the particular sort of medical condition that they're interested in discovering more about. So it will change the way that we use computers. It's like it's part of that evolutionary step of how we use computers. We've gone from machine code to programming, compilers and programming languages, and then higher meta type programming environments that people use today, and this will just be another step where anybody can tell a computer what to do. Does that lead to people being able to say, what the chip should do? Perhaps, certainly at a high level, but, getting the timing in chips and, some of the verification in chips is really difficult. But again, people are working on simulators, for example, that use AI to help reduce the verification load on chip development, for example. So AI is going to have a massive impact in terms of how chips get designed and built as well.
Yeah. So, I mean, I think we can, I feel like I've been on a seminar with a PhD of history, science, philosophy, great quotes from people who I've never heard of, and words that I can't pronounce. But I think this is a very natural. What's interesting the way that you talk about this, and you are a technologist, so there was always two sides to this interview. There's one which was for our community, understanding how this incremental world is going to keep growing, and then there was the sort of outside world discussion.
Yeah.
About how AI is going to affect our world.
So I titled the book How AI Thinks, and that's actually turned out to be quite a controversial title because language is a form of encoding. So I use words and I talk to you in using these words, and I assume that your understanding of that word is the same as my understanding of the word. So when I say think is actually a very controversial word. What does thinking actually mean?
Totally.
So most people probably associate it with the very conscious thoughts that you have, the very obvious kind of top of mind thinking that you have. But one of the analogies I use in the book is hitting a tennis ball. There's a lot of thinking involved in hitting a tennis ball. But if you actually think about it too much, if you try and engage your conscious mind to do that, you're probably going to miss the ball because you're too slow.
Chaos will reign.
Unless you can actually kind of embed it as subconscious ways of thinking, judging the ball, the flight, the bounce, the spin, getting in the right position, what shot to use. You're not going to be very good at tennis, like I'm not very good at tennis. But, professional players, studies have been done that show the professional players don't have faster reflexes. They've just got better thinking processes that understand how the flight of the ball goes and they understand it and they respond to it quicker because they're using a better set of algorithms, they're using a better set of methods to actually understand it. And so, this idea of what does thinking mean, it's really, it's quite a controversial thing. People kind of think of it as being to do with consciousness and, but bees talk, right? They don't talk in the way that we talk, but a bee that finds a new source of nectar will fly back to the hive and they'll do something called a waggle dance where they'll move around and they'll show the other bees where this new source of nectar is. And it might be the other side of a hill, it might be quite far away, but they'll show the other bees where they can go and find this. So they're actually communicating. So are bees conscious?
Yes, and that's a very interesting. We had a little chat before this, and I'm reading at the same time a book called *Sapiens*, and it talks about bees and whether they do think or whether they communicate, and the difference between the human construct of thinking and how the natural world thinks.
Yeah, but what Yuval Harari gets wrong is he talks about an algorithm as though somehow there's a step-by-step process that explains consciousness, and the reality is, it's incredibly difficult. The complex side of consciousness is, and again, we'll delve into areas of abstractness here, but you live in a very high-dimensional world. We think of place and time, maybe 4 dimensions is kind of what our brain is used to dealing with. But the reality is, when you see a sunset, what is that triggering that causes you to go, oh wow, that's amazing? You're triggering all these different things that
millions of years of evolution.
Cause that reaction, because this is something exciting and novel and different. You taste a unique piece of food. It's like you're triggering all these different senses that are causing you to kind of come up with, wow, this is unique and different. And that's kind of, AI will kind of get us there, but will it be as rich and capable? Is my consciousness the same as yours? When I see something that, astonishes me, you might think, oh, that's nonsense. And, I'm not interested in that at all, I go to a play and I see a fabulous play and you go...
I got a feeling we probably...
You probably want to go...
watch different plays.
You probably go...
we watch different plays, Nigel.
To go to a shoot-'em-up movie or something and think that's amazing, right?
Yeah.
So, it's the way in which we react to things is very different. And a machine, if it was even to show something that looks like consciousness, it's just a simulation.
Yes.
It's something we've embedded in it to make it look a bit like... it's following a method that looks a bit like human consciousness. So this whole idea of, thinking, a machine will think differently to a human. It will use a method that is put in there by humans, and we ultimately are in control of it. There is the alignment problem where, is it following, the instructions or the direction that we set for it properly. So how do we test that? And these are very complicated systems. So how do we know that it's doing what we want it to do? Can we build systems that actually allow it, as these AI systems get better and better, can we build systems that allow us to control it and ensure that it follows the intentions of what we set for it? But, that's the same as aircraft and, the issues of, them falling out of the sky and accidents and how you investigate them afterwards. We're going to need to be really thoughtful about how these things are work. And the bottom line is, the real danger here is the humans.
In total agreement with you. It is humans that are the problem, not the AI.
It doesn't take a sophisticated AI. It doesn't take any AI to put a drone in the air and fly it into a group of people and explode a bomb.
Or even make that decision.
But we should never allow the AI to make that decision for us. There should always be a human in the loop. And some of those things are just obvious regulatory issues that we should deal with, where we just say, that's illegal. It's illegal for you to make a deep fake of Nigel and put it on your video program. This should be a real Nigel talking to you here. And if you were to do a deep fake of me, then that should be an illegal act.
Yeah. Well, I think that... apart from the fact that I'm now completely exhausted listening to Nigel, not because he's exhausting, but because he keeps coming up with all these references and words that I clearly don't understand, that's been a very enjoyable discussion. And I think from our design engineering community's point of view, we've learned about how there's going to be a very incremental journey. Keep going on that incremental journey. Keep exploring how AI can help you build better systems. And then the second half of the discussion is, AI is a safe place for us to explore, and it's going to bring great benefit. But as human beings, we've got to understand that we're in charge of that.
And that's kind of why I wrote the book. This is how can we help people understand more about AIs so that everybody can be involved in that debate, and everybody can have a voice to say, oh, this is where we need to think about what could go wrong and where we need to add the controls. So yeah, very much so.
Good. Thank you, Nigel.
Pleasure.
Hey, yo, where my engineers at?